So this is the first period video. I'll be working 1, 4, and 7. Alright, so number 1. 7 plus 3x cubed equals 2xy squared. Find dy dx. Okay, that's about as straightforward a question as you can get. Alright, take the derivative of all the pieces. Dy dx is going to show up somewhere. And then we'll solve for dy dx. So d dx to all of that. Even though I'm recording, I can still use popsicle sticks to get some help. Three people's help here. Alan, how about 7? What's the derivative of 7? 0. Leo, how about the derivative of 3x cubed? 9x squared. Andrew, that would be a tricky one, so let me just ask it this way. What rule am I going to need to use for 2xy squared? Product rule. So I'll do the first times derivative of the second plus the other way around. And I'm just going to attach the 2 to the x. It's got to go somewhere, so I'll just attach it to the x. So first is 2x. What's the derivative of y squared? dy dx. Yes, 2y dy dx. Plus the other way around, the second is y squared. And the derivative of 2x is 2. Okay, so I've got dy dx. Just a little bit of algebra and I'll be there. 9x squared minus 2y squared equals 4xy dy dx. So divide by 4xy. And there's my answer choice, letter A. Again, that's the most straightforward, easiest question we could ask, like, from this unit. I mean, I had a product rule in there, but you got to be able to do a little bit here. Number 4, word problem. So this is going to be related rates rather than just implicit differentiation. But again, related rates uses implicit, so that's why they go together. A 13-foot ladder is leaning against a building. The top of the ladder is sliding down the building at a constant rate of 5 feet per minute. At what rate in radians per minute, so we're looking for an angle, actually not really an angle, but a d theta dt, a change in angle. Find d theta dt. Is the angle between the ladder and the ground, changing when the base of the ladder is 7 feet from the building? Well, let's label some of this stuff. So x and y. So when x is 7. Find d theta dt when x is 7. Okay, so I need to write everything down. Oh, what is 5 feet per minute in terms of my variables? dy, careful, dy dt. It's how y is changing with respect to t. What else do I need to be careful of? If I say the word, you'll automatically know what I'm talking about. Anybody know what I'm fishing for here? Something's not quite right on what I've written down. Negative. The y is changing, y is shrinking, so it's negative. Now, given this problem and all my answer choices are negative, my guess is if I didn't have that negative, my answer would turn out positive, and hopefully I figured out what's going on, but that's not always the case. So be careful with the negatives on these word problems. Alright, so I need an equation with theta and with well, I have dy dt, so I should probably find something with theta and with y. So an equation with theta and y. Sine of theta equals opposite over adjacent, y over 13. Then I could take a derivative here. I don't remember which class it was. We were doing a problem like this, and someone's like, well, why don't we multiply by 13 first? That way we don't have fractions. I like that. Let's do that. So 13 sine theta equals y. Then we'll take the derivative of everything with respect to t. What's the derivative of sine? Cosine. Let me ask it a little bit differently. What's the derivative of sine of theta with respect to t? The answer is cosine theta d theta dt. And then the other side would just be dy dt. Now there's sort of a built-in check on some of these. I'm worried you're going to forget the d theta dt, but on this problem, if you forgot the d theta dt, and so you're left with 13 cosine theta equals dy dt, and you know you're trying to find d theta dt, it's like, well, clearly something's not right here because you don't have a d theta dt. So hopefully if that happens, you realize, wait a minute, I need that d theta dt in there, and then that's what we're looking for.
Hypothetically, could you do like cosine of x over 13 instead of sine of 13?
So if you did cosine of theta equals x over 13. Okay, so you're going to have a d theta dt on this side. You're going to have a dx dt on this side. The trouble is you don't have anything about x.
Oh, okay, got it.
At least dx dt. You have when x is 7, but that's an easy one to account for. If you were going to do it this way, you would have to then use x squared plus y squared equals 13 squared to figure out how x and y are related to each other. So could you do it? Yes, but it's extra work. Okay, back to this question. So 13, or no, let's solve for d theta dt. No, that's the math teacher way to do it. Let's do it the student way, because student way is probably better on this one. 13. Cosine of theta is adjacent over opposite, and now it turns out it's very convenient that they gave me 7 as the x, because that's cosine of 7/13. dy dt is negative 5. 13s cancel. And so d theta dt is negative 5/7. This one didn't ask for units, but just in case, radians per minute. So sometimes we give you the equation to take a derivative of, sometimes we expect you to come up with it. Like sine of theta equals opposite over hypotenuse. Number 7. Good, so here's an example of one where we give you the equation. 4/3 pi r cubed. A spherical snowball is melting in such a way that it maintains its shape. Okay, that's good, right? That means it's always a sphere. If it was melting some other way, then I don't know how we would work that problem. The snowball is decreasing in volume at a constant rate of 6 cubic centimeters per hour. So, Monty, put you on the spot here. What is 6 cubic centimeters per hour in terms of variables in this equation? Good. dv dt. Anything else about that you don't like? Yeah, why negative? It's decreasing. Again, almost always or I phrase it the other way, almost never does the problem say negative. You will usually have to use the decreasing, going down, falling down the wall, getting smaller, something like that. At what rate, in centimeters per hour, is the radius of the snowball decreasing? So find dr dt when r equals 8. Okay, so v and r means I need an equation with v and r. They were kind enough to give us one. So let's take the derivative of this equation with respect to time. So dv dt on the left side, and on the right side, Kira, what's the derivative of 4/3 pi r cubed? Good. Again, like you know the power rule. So she got the derivative right, 4 pi r squared. She almost forgot the dr dt. Again, another one where you're trying to find dr dt. So hopefully, if Kira had left that off and then tried to work the rest of the problem, hopefully you'd realize, wait a minute, why there's still no dr dt showing up? What did I do wrong? Well, chain rule, you got to include that dr dt. So -6 equals 4 pi 8 squared dr dt. Again, show your work, partial credit. So -6 over 4 pi 64. That's not reduced yet, but the 6 and the 4 can be 3 and 2. And then 2 times 64 is 128. So 3 over 128 pi. I said negative. My answer, I don't have any negative answer choices. Does that make sense based on how the question is asked, though? Because it says, how is it decreasing? So I wouldn't say it's decreasing at a negative. I'd say it's changing at a negative, but it's decreasing at a positive. Now, again, I don't think we did that on the test, or we test that on the test where like one of these is negative and one's positive, and we expect you to put the positive because the word said decreasing. Like that's just cruel. So that explains why my answer choices are positive, because the question was, it's decreasing. Okay, so go check out the other videos if you want the other ones. Second period will be 258, and fifth period will be 369.